Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll speak about one of the most hard challenges for the projects, for the landscaping projects. That's the water. And we'll try to find some solutions to solve the problems for the architecturals and to have a sustainable project without problems. Unfortunately, most of us have seen a project with a very nice landscaping in the beginning, but after a few months or years, because of lack of water, we don't have that beautiful landscape, and most of the grass area converted to bare soil or to anything else. So from the beginning, it's our target to find a solution to have a sustainable project and to solve the problem before costing and before implementing the landscaping and change it to something else. So we have three subjects for today. Okay. We'll speak about using the recycled water or the used water for the irrigation, which is the treated sewage effluent. And the second subject we will speak about the water conservation. How can we save water with projects? The third subject is the challenges in the irrigation with the harsh environment and the hard environment, and how can we deal with it. So we'll start a very important question. When we start designing urban design or a landscape in a city or a big project, a big commercial project, what's the first step we need to do to have a sustainable project? Actually, wherever we have a softscape and plants, we must look for the water. Water is not only the quantity, but we need to look for the quantity and for the quality of that water. That takes us to the sources of water in Saudi Arabia here. What's the available sources of water? We have mostly three. The main source of irrigation water here is the wells and the underground water. Unfortunately, most of the underground water, the well water, is salt water. It doesn't give us that quality to have the nice landscaping and to be able to plant the sensitive plants and the projects. So in some areas like Najran and Jof, they are lucky they have a good quality of water from the underground and by the wells, but in Jeddah, in Riyadh, in most of the cities, it's not that good quality of water to be able to plant a nice landscaping with that water. So if we are using the wells or the deep wells, water from the deep wells, we need to select our plants carefully and to avoid using the sensitive plants in our design. Other solution to have a better quality of water, to make the RO plants or the desalination of the wells, of the water coming from the wells or from the sea. The RO plant has some problems and it's not that easy to implement it anywhere without any restrictions. RO plant has some issues. It's a high cost. It needs a closed area, air-conditioned area. It's consuming chemicals. It's an unsustainable system. It's not an eco-friendly system. It's consuming chemicals and discharging salt water. It gives us approximately 70 or 60% from the raw water we are processing in the RO plant, and 30 to 40% is a rejected. It is a very high salt water need to be discharged to somewhere. So it's not that easy, and it's costly. This diagram just to show the procedures of the RO plant. We have the raw water. We have filters. That filters will be replaced periodically, and we have a chemicals injection, 3 or 4 types of chemical injections. We have pumps. This place must be air conditioned, and we have the filters. We have the membrane with a limited lifetime and need to be changed also within months or years as per the quality of the water. Changing the water quality, giving us problems with the membrane, and the raw water itself is not guaranteed by the wells. We expect the wells maybe will be dry, or we can expect some elements in the water makes problem with the RO plant. So it's not the best solution for us to use the RO plant, or to be used with in a limitation for some purposes. The last source, and it's our target, and it's the subject of today, is the treated sewage water, or the treated sewage effluent. The treated sewage effluent, treating the water is a must anyway, even you will irrigate with it or you will not irrigate with it. The sewage must have a process to be discharged to anywhere, so it will be treated anyway. Using the treated water, saving the underground water cost, and also it's a way to discharge the water from the treatment plant. Some consideration or some special considerations also and challenges with the treated water. And the new cities like King Abdullah, Kilmakan City, or any new city, we didn't expect that much population as it was planned. So we didn't get that productivity as it was expected. That takes us to alternatives, and we must have alternatives, especially in the vacation times, which is against the requirement of the plants. And the summer, when most of the people leave the country for vacations, and it's the time of the peak demand of the plants at the same time, so it's against our desire. We need more water at the summertime, but it doesn't give us enough water in the summertime because most of the people left the country. Starting the construction of the treated water plant is costly, but it's one time and it's a must for the sewage, so it's not that problem as per in the RO plants. We expect the TDS of the water, or the total dissolved solids of that water, is not like the potable water. It has a salinity, but could be acceptable for the plants. Within 800 and 1000 is very good. It's very good to say that in Al-Hassa, more than 600,000 meter cube produced every day to irrigate the palm trees there. And we wish that could be implemented in Jeddah and Riyadh as well. The TSE is a must for the future, and we need to plan to do it. We'll speak about some facts about the treatment plants, how it works, just to understand the outlines of the treated plant. Here is a very big plant. Shows us the stages of the treatment. We have the screening for the big solids, and we have the sedimentation. This is the raw water collection, and we have the screening for the big solids, which will be being taken out, and the sedimentation for different stages. We can get from the sedimentation a fertilizer, and we can get energy as well by the gas to be discharged to our turbines and to produce an electricity. Well, this sample has also another alternative solution for the power, which is the solar panels beside the gas and turbines to produce the electricity. We have here the sedimentation tanks, and we have the disinfection by chlorination and some new technologies by UV or ozone. And finally, this water here doesn't make problem for the environment. It could be discharged to the water or to anywhere without problem. We can have more stages for treatment. We can have some odor control. We can have better filtration system, and we can get the quality of the water like exactly the drinking water with some processes by adding the membrane to the filtration steps. So the TSA water quality, we need to agree that it's not affixed according to the procedure and to the treatment stages. We expect different type of quality according to the treatment stages. It could have some smell or some bacteria or some, and it could be like the potable water as per the procedure of the treatment we did. We have here some restrictions or some recommendation when we are using the reclaimed water in our irrigation system. We need to post a signage that indicates that this is a reclaimed or TSE water. Sometimes when you have odor, it's recommended to irrigate at the night time, not at the morning time when there is no people at the place. Prevent the water from ponding or running into the other properties. Avoid overspray to the walkways. Wash with soap. Wash hands with soap and drinking water if you get in contact with the TSA water. Use the purple color indicator with the equipment. Advise the landscaper and the maintenance team that this water is treated water. Reclaimed water guidelines don't use in for human consumption. Don't connect it to the drinking water lines. Don't bath or swim with the reclaimed water. Don't irrigate the herbal or leaf groups with the treated water. Don't use it in the heating or cooling equipment, like in the chillers or the boilers. Don't connect it to fountain. Don't use it to wash vehicles or play equipment. What we expect from the TSA water, we expect bacterial presence. We expect odor in some cases if there is no treatment for the odor. We expect TDS higher than the potable water. We expect impurity. We expect high chlorine and no clear limit of the pH. Now we move in what's the recommendation when we are implementing network using the TSE water. Our concern first is the material. We need to use the products for the TSE water. For the pumps, we recommend to use the stainless steel component pump because of the chemicals. For the irrigation accessories, there is no problem mostly with the pipes. We can use many type of pipes with the chlorine it's not affected with the chlorine, but with the solenoid valves and the accessories, we have some special requirements, especially with the rubber items. The rubber need to be built from a material work with the chlorine and with the high chlorine. And also, we need to implement good filtration. We need to have something called a scrubber with the solenoid valve here with the filter, because it's a very fine filter, and the scrubber is scrubbing the filter to avoid the accumulation of the bacteria and the gel on this filter. It's recommended to use the impact sprinkler because it's kind of flushing the system itself. using the purple color valve boxes. And also for the sprinklers, we have the Weber seal splitter to be built from chlorine resistance material. This is the subject for the TSA water, and there is another problem and an understanding of the nature of the TSA water, the impurity. We say that the quality of the TSA water could be like a drinking water or like a potable water, and it could have some smell or some other factors mentioned in the presentation, but mostly the impurity, or what we call it in Islam, najasa, that's still considered by many peoples, and they still avoid using the TSA water because of this reason. I will not speak about their beliefs, but I will speak about using them in the places with no contacts with the human being. We can use it with the green belts around the city. We can use it with the trees only, not with the lawn, if there is a problem with the beliefs in this issue. We'll move now to the water conservation. We need also to understand a very important thing before starting this, the water cycle. Some products and some manufacturers mention that their product is saving 90% or 80% of water. They did not explain how it is, but we will try to facilitate this issue and to understand how can we save water and what's our target from the irrigation. This is the water cycle, and we have the rain or the irrigation. After that, we have the infiltration. This is our target, is the root zone area. We targeting the water to reach the root zone area and to be here until it's absorbed by the roots. What we don't like is the evaporation. When we have a ponding or accumulation of water above ground, the water evaporates and we lost that water. We need to avoid the runoff. If there is a spray out of the walkways or out of the green area, the water will go out of the planted area and it's a wasted water. We also need to avoid the deep drainage of water. If we have excessive water, the water will go deeper than our roots, and it's also kind of wasting the water. Here, understanding the soil nature. If we have a clay water, it holds the water more than the loamy, more than the sand. If we have the same quantity of water here given to 3 different types of soil, the clay will hold the water around the roots. The loamy soil the water will go below the roots. The sandy soil, we will have most of the water going after the roots. So what we need is to give the exact volume of water according to the soil nature. For the loamy water, for the clay, we can give more water. For the loamy, we need to give it low volume irrigation devices. For the sand, it's like the mesh exactly, so we need to give a very, very low volume irrigation devices. So we need to study the nature of the soil, study the soil topography, study the plant type and the root depth, study the evapotranspiration rate and adjust it with the water stations, select the right devices for the irrigation according to the previous factors. Our water saving trends is maximizing the efficiency and uniformity of the irrigation efficiency, use drain check valves to avoid the runoff, use pressure compensated and regulated devices, or the pressure regulator generally and with the networks. Use the low volume and precipitation rate to avoid the runoff and the effect of the wind. Use the water-based irrigation controller, cycle and soak feature to keep the water on with the slopes. We don't need to give that much water. Then it will be, we will have runoff and we will lose that water. Try to prevent the leakage and detect the leakage with the smart controllers and the flow meters. Finally, we need to keep our operation and maintenance in the best condition to save the water. We have here some photos and examples for the problems and how to solve these problems. We have here the uniformity problem. If we don't have the good uniformity in the design and in the used devices, it leads us to longer irrigation time. This is drainage when you have a sloping area. The static pressure in the pipes discharge the water from the sprinklers, and in this case we need to install a check valve with the sprinklers to avoid this leakage. The high pressure, if we have a high pressure, this is, gives us a small droplets which be moving easily by the wind and taken out of the planted area to the walkway or to somewhere else. And also the possibility of the evaporation here is higher than the big droplets. So we are controlling the pressure to save the water by avoiding the fogging in the sprinkler systems. Here we have the pressure regulated sprinkler when it's broken, and the non-pressure regulated sprinkler, it's wasting more water. We have some other solutions to save the water except the irrigation devices. It's in the design stages, like minimize using the natural plants with the high requirement. Let's just imagine the golf course consuming consuming irrigation water as much as the consumption of the 35,000 person from the potable water. So it needs to be reviewed very well. What's the purpose of the golf courses and the efficiency of these golf courses in our country? We need to find solutions by the hardscape, using the gravel, using the hardscape instead of the natural plants. Another issue with the artificial grass, we all like the natural grass, but some places we are not in contact with them, like the roundabouts, like the flyovers, like the highways. Nobody is there. Nobody will feel that grass. So in this case, we must make it the synthetic or artificial grass. And also another problem is the hazard of the maintenance and the availability of water in that places. The maintenance people facing hazards to move around the highways and the high-speed roads, and solving this problem by using the artificial and the hardscape solutions. Enhancing the soil structure by using the additives is giving us better performance of irrigation and allows keeping the irrigation water in the soil. Blending the water if we have RO plants. If we have RO plants, usually the TDS of the water is less than 150 ppm, which is the drinking water. But for the plants, within less than 800, 1000, it gives us perfect results. So if we have a sweet water, we could blend it with the salt water. The last point is working with the irrigation in the harsh environment. We have the hard weather, we have the hot weather, wind, dust. We highly recommend to install the smart irrigation control system with weather station that will adapt itself according to the factors of the weather, wind and temperature, humidity. It adjusted itself according to the different factors. lack of water, we need to save water by what we have mentioned here and to find solutions. If we have a salt water, we can use the salt tolerated plants to have a landscape, a sustainable landscape. The high cost, sure, but the harsh environment, we have higher cost than anywhere else. And finally, the maintenance cost, we can reduce the maintenance cost by implementing the smart irrigation controllers and the SCADA system to monitor and view and control the irrigation with less number of laborers. That's what we have for today, and thank you.
Thank you, Ahmed. I'm sure our audience will appreciate all those technical irrigation information.